complex problem. In fact, open networking, the ONM guys are now challenging that. All this software-defined network and software-defined data center is challenging some of those basic protocols. But defining SLAs and the processes, nailing down, how to what all an SLA should address. It should address security and privacy. It should address service management, failure, disaster recovery, management process, exit process. For every application, you should have this in place. This is the OpenStack Foundation. So the OpenStack Foundation, in I think less than 2 years, scaled to. They are saying that this the basic module was built. This is 2011. I met this guy last year, and they scaled to more than I think 5,000-6,000 developers now. And they are all over the globe. There are around 2,000 developers from India itself. And the Bangalore branch is the most prolific contributor now. Okay. So this came, I think Red Hat and Rackspace and NASA, yeah, they came together and they started building an OpenStack because VMware monopolizes the virtualization world. So they wanted to develop a cloud solution which is not dependent on VMware, right? So all these companies have come together and it's all over the world, and it's making a big difference in what is happening in cloud, in the cloud story. Now talking about interoperability, what I want to show you is from one of the interoperability efforts, the GICTF, which is driven out of Japan. Here are some of the use cases they have defined on what an interoperable cloud, similar an intercloud, so to say. Like internet today, if we have an intercloud happening, what are some of the use cases that you need, that should work on that environment, right? And that's what they're using. So the first one is guaranteed performance against abrupt load increase. So you have an application, you're running your application on the cloud, and suddenly the amount of users accessing your application, the load increases. Seamlessly, it should scale. But your service provider may not have the resources to scale it. So such a service provider already, based on your SLA, the service provider has negotiated SLAs with other cloud service providers so that when he runs out of capacity, he can go and get capacity from somebody else. And that's essentially what happens, right? When you have two services running simultaneously, one of them gets overloaded, there's an SLA in place, the traffic immediately gets directed to the other service provider. All of this needs standards. Guaranteed performance at remote location. So you have signed up a service with a certain SLA with a service provider who has his services in your geography. Now you take a flight and go to the other part of the world. But you want the same guarantee on SLAs in terms of performance.
One question, the previous slide. So such a thing has to happen, based on the capacity, the inter-cloud movement has to happen. Do we expect that at the infrastructure level, we talked about platform as a service or infrastructure as a service, do we expect that the other clouds will also have similar infrastructure? How does that happen?
That's where you need the standard, right? They need to be able to seamlessly, dynamically transfer load. Your virtual machine, right, gets transferred, or virtual machines with your requirements get created there, and at the user level, traffic gets rerouted there. So that requires standards, requires negotiations. Negotiations will happen only if there are standards and there is compliance to those standards. Okay, this is the same story I just told you, right? Guaranteed availability in the event. We all talk about disaster recovery. Now, disaster recovery can happen with the site, a disaster recovery site from the same service provider, but you could use some other service provider, right? So this essentially shows that a priori you have set up your disaster recovery requirements. So every time you're when you are changing your information, the database gets synchronized at the disaster recovery site as well, automatically. And there may be multiple sites, right? Instead of one site, you may have 2 disaster recovery sites where you're doing, depending on the quality of SLA that you need. And when the disaster strikes, automatically your traffic gets routed there.
I have a question.
Yeah.
With this intercloud concept, and you have like the speakers earlier saying that geography is a constraint of transferring data here and there.
Right.
So is intercloud really going to make significance there? Because you know that geographically this is going to be a constraint.
So
and
if the government's demand that geography is a constraint, the business will do the right thing to comply. Nobody's going to break the law, right? They will put redundancy. But as a technical person, I think these boundaries are going to disappear. It's a matter of time. Texas Instruments. When Texas Instruments set up its R&D center in Bangalore, they were sending data over a satellite dish. They were doing the designs here, right? The chips were getting designed here and the data was being sent to Dallas over a satellite dish, which was, enabled by some government which was providing these, I don't know which body it was, maybe BSNL or whatever was, right? Was the DOT was providing this leased satellites link for Texas Instruments. But the government, the tax department or the secure home affairs department or whatever had a law. There was that any data being sent out, they should audit. Now, how do they audit? There was a guy put from the income tax department or I don't know, security department, whatever. He was positioned in Texas Instruments in the room where that dish was located, and there was a printer connected to the dish where every bit of data was being printed out on hard copy of that was being maintained in these audit files. It was required by the law. So law changes a little slowly. When it becomes redundant, they have to change it. Technology moves faster. That's my experience. So I would think more in terms of business. How do we make ourselves a viable player? Look at what Singapore is doing. Singapore government today has defined a cloud policy and they are putting everything in place, every regulation in place to become the cloud data center of the world. Like they are the trading hub of the world, they want to become the cloud. They want every bit of information across the world either to be stored there or to move through Singapore. Okay? So they have an amazing vision. So, service we are talking about Aadhaar. Aadhaar is a key example. So what we are calling that government common platform for authentication, that's exactly the example here. Ministry of Foreign Affairs. So there are different people who access the same database for authentication, right? And they interoperate in a cloud environment. So the person is an employee, he goes to for his passport, he goes to from the municipality, he's paying some bills or something like that, or as a citizen of a city. So all these things that he does, they all go to the municipality cloud, to the government platform for his authentication. Because every time he does something, he gets authenticated using his number. And all of that goes here for final authentication. And you need inter-cloud kind of an environment to enable that. Service continuity. So you signed up with a service provider and he went out of business. If there is no standards on the data and information, he had his proprietary stuff, you're doomed. Right? Converting all of that to somebody else, it's a big exercise, it's a big cost. Who's going to pay that cost? I come from the semiconductor world. In the semiconductor world, it's a real problem. When you build a chip with one fab's libraries, you cannot take the high-level VHDL code or your design, especially an analog design, mixed signal design, the layouts and everything, and just take the GDS2 file and move it to another fab. It doesn't work. You have to redo the and in the telecom world, this is a big problem because you put the equipment in and it stays for 20 years. You don't change those devices. You don't upgrade most of the telecom switch, right? They don't upgrade it for 20 years or more. upgrade the software. They may upgrade the CPU complex and maybe some links, right? Copper has been replaced by fiber or something. But the core, all the terminal unit and all those things, signaling chips and all, they don't get replaced, right? So, but if the cards get spoiled and the cards have to be repaired and you need the components. So it's a big thing. In fact, IBM made a big business out of this. The Burlington fab in IBM went and took the designs. So there were fabs which were running at loss. ST Micro fabs in Europe and France, other places, several companies, small fabs, which were there only because they had signed this agreement that they will keep providing one particular very critical component. Rest of it, the fab was empty and it was running at loss. So IBM went to such fabs, converted their libraries into, brought their business into the Burlington fab, okay, became a multi-node provider. They designed that, and that's how they stayed in business, and these fabs could all be shut down. So that's a similar problem here. If there are no standards that your application can easily be portable from one service provider to the other, then every time a service provider goes out of business, you're in trouble. And that's what the government guys say. So when I was talking to government of Karnataka the other day, they want to go to cloud. They are setting up the state data center. I was looking up the RFP. I said everything here you are going to the big four is all that you will talk to. You are not going to encourage anybody, any startup in India, anybody to come and work, be a service provider to you to compete on this RFP. They said no, they are scared. They'll come today, they're gone tomorrow. You see, it's a real concern. But standard solves that problem. Market transactions, we have brokers. So I talked about the broker concept. So this is a vision, right? That a consumer goes to a broker and defines his SLAs. The broker goes out to all the service providers and ensures the SLAs. If somebody goes out of business or something, brokers can come into existence only if those standards and interoperability are guaranteed. That's the reason brokers are not coming into being. So this is here the vision, right, of the intercloud. This is IEEE. IEEE has a group P2302 which is looking at intercloud interoperability. And this is their vision. So dynamic workload migration. So dynamically, we talked about it, right? So you have an infrastructure as a service, you're using one service provider, like mobile. Earlier, if you signed up with Tata, you signed up with this Bharti, you're logged in. Now what happens, you sign up, number portability is also there, and there is agreements in your area, this Vodafone may not have a base station, but he will use a Bharti base station to provide you that service, right? That's because standards are in place. Application integrated services from multiple clouds. We talked about the Aadhaar integrating with the other applications. Then the federation of clouds. So for brokerage, you need a standard for SLAs that you sign up and the information about the service provider and everything is in one template, one way, and then all kinds of interoperability can happen. For that to happen, you have to build the infrastructure, the same complex infrastructure that internet has. None of us know it, right? It's like the utility world. We all get light, but we don't know till we went to college, engineering college, if you did LA power, electrical, right? And in your power engineering course, that's when you understood that there is a generation system, there is a transmission system, there is a distribution system, and how damn complex they are. Even water supply, it's a complex distribution system, right? So it requires a lot of stuff in the background. So there's this, the root, so the DNS servers and all that in the internet world, right? There's the internet exchanges. Similarly, they are talking about intercloud exchanges. So there's an internet exchange in India. You know that? You know what it's called? Anybody knows that? It's Nixie. There's a body called Nixie, NIXI. They are essentially running the reason why we sitting in India are connected to the internet worldwide is because there is a Nixie. And everybody pays something to the Nixie, but it's managed by the government. right? So all this .in and all has come because of this. The domain names and all have happened because we are participating in that. There are global agreements in place to manage this. So same thing needs to happen in the cloud space. These gateways need to happen. Gateways are essentially like routers in the internet world. So these are the kind of infrastructure you will need. You will need the compute server, the compute networking and storage to be cloud enabled, so it compliant to certain protocols and formats and processes. You will need exchanges. Again, so the standards that will say what it needs to build an equipment which should be compliant, what the exchange needs to have, what needs to happen in the exchange, what needs to happen in the gateway, what needs to happen in the root. So there's a topology, and these are the elements of the topology, and they all will have their roles defined in the protocol. That's the only way this can happen. And obviously standard bodies and research, open source, test beds, all of this is needed feeding into making this happen. And so IEEE started the cloud computing initiative, and the first thing they did was, the perception with them was that all these societies which exist are all going to be touched, they have something to contribute to cloud computing. So they brought in people from all of them collaborated and contributed to create the cloud computing initiative, right? So from the power and energy society, the systems, reliability, consumers, standards, communications, computer society, they all came together and they have created the cloud. So it's an interdisciplinary act. It builds on all the technologies that are there. And this is the kind of stuff they do, right? So they have the standards track, they have the test bed going on, then obviously being IEEE, they have publications, education, web portal, conferences, all of that. And we added this conference, Cloud Computing for Emerging Markets in India. I was on the board of governors, then I asked them to form this conference, and we run it in Bangalore every year. So this is, you get the draft of the standard. It's very simple to join this, by the way. So I signed up for P2302, and I get the message every month or every 6 weeks they have a call, and you log into that call. It's around 9:30 because they have Pacific guys from California as well as from the East Coast. And you log in, the guys from Korea sign in, the guys from Japan sometimes, I think once there was some presentation from Argentina also. So there are professors who are doing research on different topics. They come and present, and that is getting incorporated into the standard. So research to standard is just happening seamlessly. It's amazing. It's such a huge learning experience. You get into this call, there's a guy from Huawei, there's a guy from Cisco, and then they have subgroups on particular topics. If you want to work on trust, if you want to work on SLAs, brokerage, in different aspects they have different groups. And you can and the learning is just phenomenal. And it's all open, it's free, you don't even need to be an IEEE member. So these are all the research papers. The first thing you do when you sign in, they have a portal where you get access to all these research papers. A lot of what I just downloaded these papers and started reading them. That was my starting point. They have collaborations with the trust authorities, right? They have created a test bed, and this is a flavor of what's happening with the other bodies also. You see that they are signed up with GICTF. So where is it? Somewhere down the road. Okay, so this is the test bed structure. So test bed is not just this AT&T research department in AT&T, University of Arizona, IEEE, Rackspace, all these people came together, but then they have gone and signed up with Telefonica, IGTF, GICTF, Melbourne. So they, that's how you create a real test bed. We are now making a proposal to get IIT Madras, ES University, IIIT Hyderabad, and which is the fourth one? CDAC. Okay, 4 of them have come together. We are putting a proposal for a interoperability test bed. And then we have VMware and IBM and Cisco on the next layer. We have companies coming into it, and then we are going to build this. And we want to do it locally first, and then we want to go connect globally with all of them. Now we are signing up with government of Karnataka, and we may do something similar with that. So what's the India opportunity? How much time do I have left?
Just few of the time. You can have the
Okay, okay. So I won't dwell much on this. You all know that there's every indicator that India is ready for cloud, right? In terms of usage on of Facebook and all the social media applications and mobile, right? And the business is ready for cloud. Yeah, 900 million going to 4 billion is the projection. But if you change this, if more and more what's happening, so there are two factors to this. One is the need for IT is much more than what is being projected. So if we accelerate that, we can see an exponential growth like the mobile world. The other thing is that this IT, which is being talked about as vanilla IT, will also become cloud. Right? So the 4 billion could actually be 40 billion. Government has jumped onto the cloud bandwagon. They are setting up. They already put the networking infrastructure. Now they are overlaying on it the data centers, and they are adopting the cloud, at least the private clouds at the center and the states. And these private clouds, if they become successful, will offer public cloud services. Right? Aadhaar we've already talked about. There's a Devi project going on, which is driving all of this at the center. There's Devi, there's the NIIT. All the earlier initiatives are being brought together under one umbrella called the NIIT 2.0. But still, where do we stand in the global survey of e-governance? We're number 124, sadly. And when you go to Devi, the guys are like, what should we do? We have to become a South Korea. Roadmap to become South Korea. Okay, talent-wise, you're all there, right? So, there are 395 cloud-based startups. This was in August of 2013. The roundtable in Bangalore did this survey amongst themselves. Okay, and 58% of cloud technology vendors have R&D centers in India. We have all the talent. And interestingly, I told you the IBM story. A lot of the IBM cloud work happens in Bangalore. The guys in IBM can testify and tell you. And this cloud center of excellence is being run by Gopal Pingili from Bangalore. He's a director, he's a global director for Cloud Center of Excellence. Right? Cisco has the same story. Okay? So a lot of the cloud development work is actually happening here. And this authenticates this. This is Rajpuya's slide. Rajpuya is like an evangelist on cloud. He's from University of Melbourne. So he presented this in one of our meetings. And this is a search on Google on the word cloud computing and grid computing. So the red one is cloud and the small and the blue one is grid. So the amount of, this is global numbers. So the amount of times that grid computing is getting searched versus the number of times cloud. Just see the difference. And then he analyzed this data. Where is it coming from? Which region is it from? India. Red. So India is right there on the top. Then he did a city-wise analysis. Top 10 cities. The top 6 are Hyderabad, Bangalore, Pune, Chennai, Mumbai, Delhi. You go to all these cities? You go to all these cities? You should. Oh, okay, excellent. So that's the story. Well, Hyderabad is scoring more than Bangalore, by the way. Okay. So isn't that amazing? So the Cloud Computing Council, Innovation Council of India is about bringing people who are passionate about technology, people who believe that technological innovation is needed for cloud computing to happen, people who believe that cloud computing for emerging markets requires a different type of innovation compared to what is happening in the mature geographies. Mature geographies are already 80 to 90% IT enabled. They have a huge legacy. When you talk cloud stack, when VMware talks cloud stack, what does their CTO put on top bullet? I have to protect the legacy. I asked him, there is no legacy. Why don't you build a greenfield cloud stack for a geography like ours, right? So our needs are different. We have to innovate differently. So that's basically, we brought people across the ecosystem together with the vision to be able to emerge as a global player through innovation, and also to accelerate the adoption and deployment of cloud in the country through innovation. These are the kind of things that in open forums normally do successfully, and we are attempting to do these things. We already have a white paper out. We have a white paper out. We have 100 members. We conducted 9+ workshops. We have 16 technical working groups. We have an affiliation with IEEE Standards Association Industry Connections Program. We are announcing an advisory board on the 5th of March with Chris Gopalakrishnan as our chair, and some of the key decision makers in the country on our board. And these are the working groups that we have: usage, technology, and enablement. We have the entire spectrum. We did the white paper last year. Now we are setting up task forces, looking at specific projects and working on them.
So what is cloud migration? I think if you go back some 30 to 40 years back, you heard of mainframe, correct? What was mainframe? Nothing but a centralized place where you used to have all the data residing. You will go with your punch cards, highly secured, go with your security card, and then you will do the processing, you will take your data, outputs, you come back. It was highly secured, and it was there either in the underground or the first basement, lot of security, physical security, and then logical security. Then we moved from mainframe to what you call as client server approach, either thin client or thick client. We moved to so many places in the banking industry and in many other places, and ultimately we come back to cloud. So do you think history repeats? Absolutely. And how many of you are over programming? Any of you? Yeah, good. At least I can see 3, 4. I was one of the over programmer earlier. So what we used to do is they used to have a big data center, some 150 people to manage the whole thing, all the banking application, reporting, everything. Now where we are doing now? We are thinking, let us say there are some 20 banks in India. All 20 banks are going to migrate to a cloud. Means they will not have the headache of maintaining their own servers or mainframes. They are not going to do any physical security. They are only working on only logical security to access something in servers which are hosted either in Amazon or someplace which could be globally, it will be residing somewhere, and you are going to do all that. If as a CIO or a CTO of a bank, if I want to really migrate my complete banking application to cloud, what are the challenges we are going to face? Can we do this migration? Is it really going to be cost effective? Is it really elasticity? Is a new word what we are using here, a buzzword, elasticity. Means like how can I scale up or how can I scale down at any moment of time? So I want, let us say, to do some credit card processing happening where I'm billions of data, trillions of data on credit card processing. Can I do it instead of doing it for 8 hours, can I do it in 2 hours? And this month, I may have more data to process or less data to process, depending on